Alrighty, so here's a little bonus optional, whatever you want to call a video, basically how to use the law of cosines with the ambiguous side-side angle case. Just from experience, people tend to have a little bit of trouble with the law of sines thing, with the ambiguous case, because you have to consider, okay, does the supplement make sense, yes or no, and all kinds of stuff. And so here's another way around it, just a second option. If we want to use it, great. If you want to totally not use it, great. Just pick one of the two methods and stick with it. But here we go. Alright, so let's just pretend for a second we've got this kind of situation here. We've got A, B, C, or at least parts of A, B, and C. Got a triangle here. A is 46 degrees, so I'll squeeze that in there. 13 for little a, and then C is 9, so there we go. Okay, so again, from here, normally we'd use the law of sines with that, and we'd have to find C first, and then we'd have to ask C, okay, does it make sense if the supplement of C, and whatever. Okay, but, as it says up here, if I plug this stuff into the law of sines, or law of cosines rather, okay, I'm going to get something, but let's take a look at what we get, and maybe we can deal with that. Okay, well, first thing first, if I'm going to use the law of cosines, I have to use this 46 degree angle, because quite honestly, it's the only angle we have. Alright, and if I'm using the 46 degree angle, the number that goes on the left side of the equal sign is the side opposite squared. So basically, my formula is going to start out with a 13 squared. Okay, from there, I need the other two sides, and wait a minute, I'm missing one of them. So basically, there's my variable b. Okay, of course, you could use an x or whatever if you wanted to, but I'm going to stick with b because that's what we've been using. Alright, so 13 squared equals the two sides that are around that angle squared. So I'm going to have a 9 squared plus b squared. Okay, now that's a little bit weird, but it's what we have. Alright, now minus 2 times, and again, the product of these two guys, so 9 times b. Again, that's a little bit unusual place to have a variable, but hey, it's what it is. And then finally the cosine of 46. Alright, and again, this is basically a quadratic, because we have a variable squared, and then we have a variable of first power, and then we have some other constant terms lying around. So basically we can solve this, but I'm going to do the next slide, but that's basically what we have here. We got a quadratic, and if we can work with it, then we got something we can kind of deal with maybe. Okay, just to preface what we have here, but if you notice I've just simply copied the things from the previous slide onto here. Okay, if I'm going to do side-side angle with the law of cosines, I do have to be careful about a couple things, but again, first of all, side-side angle was that whole, okay, do I have 0, 1, or 2 triangles, and it kind of depends on how the numbers play out. Alright, so, okay, again, I'm looking at this sort of equation right here, and again, I'm looking at a b squared and then a b to the first, so effectively I'm looking at a quadratic. Granted, it's a little bit messy right now, but what I'd like to do right now is kind of rearrange it so it's in a nice descending order sort of setup, and get rid of the 13 squared on the other side by subtracting it off as well. If I do that, I eventually get a 0 on the left. I've got this b squared that'll just bring it first, and then, gotta be careful about this here, but I've got the 2 times 9, that's an 18, and then I've got the cosine 46, which again is really a number. It's some icky decimal that I'm not going to multiply out right now. So I've really got negative 18 cosine 46, and just for clarity's sake, I'm going to throw that thing in parentheses, although I realize that the negative sign does come with it, and that's my b coefficient, if you will. So basically negative 18 cosine 46 is my b coefficient, and actually my b value if you think of the quadratic formula as well. Please don't get those confused. And then I've got the 9 squared over here, which of course 81, 13 squared, 169, and if I take 81 minus 169, I get negative 88. Alright, so basically there's my equation in maybe a nicer sort of form, and depending on your model calculator, you can probably have this solved for you, or you can graph that thing or something like that and eventually get answers for it. But whatever the case, you should eventually get values of b equals 17.525 ... and then negative 5.02 and some other messy decimal points. Okay, now I'm not going to do this whole problem now because I'm just trying to get the basic idea across here what's going on, but notice that a side angle, or a side measure, of 17.5 kind of makes sense for b. So 17.5, of course, the decimals, but that looks reasonable. But a side measure of negative 502 doesn't make sense. So basically what this has done for me now is it's given me two solutions, and it showed me one of them makes sense because it basically is a decent number for what's going on here, and the other one's negative, which can't possibly be the measure of a side of a triangle. So I basically know I can throw that out, and I only have one case to work with. And then basically from here, I'm not going to bother doing it here, but time-wise, I can now set up my sine of 46 over 13 fraction, and then again, between the 17.5 and the 9 is the smaller of the two, so I would then do sine of c over 9, get this angle here, 180 minus the other 2 gets me B. And then I've got my whole triangle solved, and it took care of whether or not I had 0, 1, or 2 based on the numbers that came out of the quadratic formula here. Alright, another situation. Hint, it's not going to be one solution, but let's see how it goes here. Alright, again, first thing first, let's sketch out a rough triangle. ABC. C is 62 degrees, big A is 94, little c is 55. Alright, and again, I'll kind of shorten this one up a little bit, but I'm going to have to start out with the 55 squared again, because again, the angle that I have is the 62, and it's across the 55. So 55 squared equals, just kind of rolling the rest of this thing out now, 94 squared, and again, I need the other side, which coincidentally ends up being the b again. Alright, so plus b squared, and minus 2 times the 2 other sides, so the 94 and the b, and then now cosine again of the angle that we have is a 62. And again, after I rearrange this thing and throw it into a quadratic formula, what actually happens is I get b equals 2 numbers with an I in them. Alright, well, hopefully the second you see that I, you go, hey, wait a minute, that makes no sense. So basically what we have here is a set of numbers that do not make a triangle. So there's no triangle that exists based on those 2 numbers. And it's because the quadratic formula gives me an I value, or depending on the mode your calculator might be in, it might just say domain error or non-real answer or something like that. But whatever the case, you get something that doesn't make sense in either value for b, so we get no triangle whatsoever. Alright, last case, hint, we haven't seen one with 2 answers yet, so here we go. So ABC, B is 37 degrees, little b is 14, and little c is 18. Alright, so again, little a is the one I don't know, and I'm going to have to try to find first, but also again, the 14 is the one across the angle that I have, so my equation is going to look like a 14 squared equals to start with. Okay, and then again, I've got the 18 and the a squared have to be the other 2. Minus 2 times 18 times a times the cosine of the thing that we have, the angle is 37 degrees. Okay, and again, moving everything over to the right-hand side and make myself a quadratic, and then typing that in, eventually gives me a equals 23.244, which makes a lot of sense. And my second quadratic formula answer is 5.506, and certainly that would make sense as well. So basically, here's my two triangle scenario, that is. And so basically you'd have to set up the one triangle with A being the 23.2, second triangle with A being the 5.506, and then find the other 2 angles based on those numbers. Alright, but anyway, using them in the quadratic formula in your calculator is a great way to identify 0, 1, or 2 cases where you're not having to sit there and go, okay, well, what's the supplement? Does it make sense or not? So anyway, there's just another option. If that made sense, great, use it. If that makes no sense whatsoever, then please don't use it. But anyway, there it is. I'll see you in class.